welcome to all dear participants. A very pleasant evening to all distinguished panelists and participants. Bharti Vidyapeeth's Institute of Computer Applications and Management, BVI CAM, in association with Computational Intelligence Society, CIS chapter of IEEE Delhi section, Computer Society chapter of IEEE Delhi section, Technology and Engineering Management Society, TEMS chapter of IEEE Delhi section, System Man and Cybernetics SMC Society chapter of IEEE Delhi section, Communication Society of IEEE Delhi section, Consultants Network Affinity CNA Group of IEEE Delhi section, Life Member Affinity LMA Group of IEEE Delhi section, Inter-Society Relations IRS Standing Committee of IEEE Delhi section, Industry Relations and Special Interest Group on Humanitarian Technology, Site Standing Committees of IEEE Delhi section, Region 10 of IEEE, with the associations of Computer Society of India, CSI, Institute of Information Technology Professionals, IITP, ISTE Delhi section, and IETE Delhi Center as technical collaborator. Welcome you all to the IEEE IETE BVI CAM technical lecture series on the topic Sustainable IT Building Greener Future Through Responsible Technologies. With immense pride and honor, we are delighted to announce that we, with united hands, mark special contribution for the monumental occasion, Golden Jubilee celebrations of the IEEE Delhi section. From 13th May 2025 to 12th May 2026, we mark 50 years of this vibrant and pioneering section, a journey that began in 1976 and has since shaped the technological and professional landscape of Northern India through innovation, collaboration, and learning. This webinar is also an initiative to celebrate this legacy. According to Elon Musk, if you don't have sustainable energy, you have unsustainable energy. The fundamental value of a company like Tesla is the degree to which it accelerates the advent of sustainable energy faster than it would otherwise occur. Global warming is no longer just a scientific concern. It's a collective responsibility that requires action at every level, starting from individuals. Each of us can make small yet impactful changes, like conserving energy, reducing electronic waste, or embracing sustainable habits that contribute to a healthier planet. However, as IT professionals and engineers, we hold an even greater potential to make a difference. The IT industry, with its vast data centers, energy hungry cloud infrastructures, and expansive digital ecosystems, has a significant environmental footprint. In this lecture, we'll explore how the principles of sustainability can be woven into the fabric of information technology. We'll examine the environmental impact of IT operations, uncover strategies for designing energy efficient cloud architectures, and learn how tools like infrastructure as a code, DevOps, and CI CD pipelines can be adapted for sustainable practices. Additionally, we'll also dive into green coding, the role of microservices in sustainability, and how optimizing algorithms can reduce resource consumption. By embracing these practices, we can not only reduce the environmental footprint of our IT solutions, but also lead the way in building a more sustainable future for the tech industry and the world at large. I would first take this opportunity to welcome amongst us our distinguished panelists for the day. We are privileged to have amongst us a galaxy of experts. I would first request Professor Emin Huda Sir, Director, Bharti Vidyapeeth's Institute of Computer Applications and Management and Chairperson, IEEE Delhi section, to address the participants with his inspiring words. Over to you, sir.
Am I audible?
Yes, sir.
So, good evening, one and all. At the outset, let me take this opportunity to welcome my valued speaker today, Mr. Sauradip Chaudhary. Sauradip is a principal engineer at Nagaro who will be introduced in detail by Dr. Ritika Vasan. I am grateful to him for having accepted my invitation and being with all of us once again for sharing his expertise on this platform IEEE BBICAM weekly evening Saturday webinar series. I also take this opportunity to welcome all my friends, Mr. Ajay, Professor Subramaniam, and all participants, very, very senior people amongst the attendees for this 211th episode of this webinar, which was started in June 2020 in the backdrop of COVID-19. Dear friends, this year from 13th of May 2025 to 12th of May 2026 is a Golden Jubilee celebration year, and this webinar has become much more important as being the part of the Golden Jubilee celebrations. My dear friend, today's session is on sustainable IT. Sustainability is otherwise a buzzword, and Dr. Ritika has introduced it in detail that how and in which way sustainability and why sustainability is important. Moreover, we have valued a speaker today who will be talking and making us to know that how a responsible use of technology can be made so that we leave enough resources for the generations to come. It is said that once you are talking sustainability, you are talking about consuming resources in a responsible manner, using resources in a responsible manner, even if it is available in abundance, so that my future generation should not repent, should not curse for the resources, and should not keep on telling that my earlier generations were not responsible while using the resources, which is the discussion for today. The change has come, and the change has come a lot. If you see, we have been talking about using resources in abundance. Earlier, the water was available in rivers. From rivers, it came to a small hand pipes. From hand pipes, it came to pipeline supply, and finally, it is being sold now in bottles. And when I'm talking of a bottles, earlier used to be big gallons, and now it is a half a liter bottle, 250 ml bottles, so much so 100 ml bottles. If like this, we have to take care of the technology, that the technology which earlier while using we might not have paid attention 20 years ago, 30 years ago, about the kind of the carbon footprint, about the kind of the impact which is going to make on in terms of compromising with the uses of the resources. So the changes have come, and if we do not accept these changes upfront and use technology in a responsible manner for the purpose of uh, ensuring that how optimal or the best or the judicious use of the technology is being made to ensure that my future generation should not have to make certain compromises. That's why I keep on saying that change is the only way of life on this earth. Nothing else is permanent. We must be ready to change upfront. We must be ready to make changes in our day-to-day life. It is not only water, it is not only the natural resources, rather it is also the resources which is being consumed by the technological advancement. And that's why IEEE also says that advancing technology for humanity. So when we are advancing technology for humanity, we are also advancing the responsible use of the technology for the humanity. So I normally say that इंसान घर बदलता है, लिबास बदलता है, रिश्ते बदलता है, दोस्त बदलता है, फिर भी परेशान क्यों रहता है? क्योंकि हम अपने आप को नहीं बदलते। तो हम अब रिस्पॉन्सिबल टेक्नोलॉजी का यूज करके अपने आप को बदलेंगे और गालिब के इस शेर को राइट सेंस में, राइट पर्सपेक्टिव में यूज करेंगे कि उम्र भर गालिब यही भूल करता रहा, धूल चेहरे पे थी और मैं आईना साफ करता रहा। जो लोग आज ये कहते हैं कि इलेक्ट्रिक व्हीकल्स हैं तो बैटरियां होंगी और इस तरह की टेक्नोलॉजी में हमारी सस्टेनेबिलिटी कहीं ना कहीं कंप्रोमाइज होगी, मैं उनसे कहना चाहता हूं कि टेक्नोलॉजी का कंट्रीब्यूशन कम है, हमारे माइंडसेट का कंट्रीब्यूशन ज्यादा है। लेट्स यूज टेक्नोलॉजी इन सच ए वे दैट वी लीव एनफ रिसोर्सेज फॉर द जनरेशंस टू कम, एंड वी शुड बी द चैंपियंस of promoting sustainability. Thank you so much. Wish you all the best. Other webinars on other Saturdays have also been notified. If you have not registered, please register. Recording of all these webinars are available through our YouTube channel. Keep driving benefit. Once you drive benefit in maximum numbers, that helps us, that encourages us, that motivates us, that maintain our enthusiasm. So thank you so much. Wish you all the best. God bless you all. Over to you, Dr. Litika.
Thank you, sir. Thank you for the motivating words. With this, we welcome amongst ourselves our expert, Mr. Sauradipta Chaudhary, sir, with an e-booking. Welcome to the session, sir.
And this entire change from physical mode to online mode is also part of the same sustainability. We haven't plugged any flower, yet the flower is available. एंड इस फ्लावर के लिए जो हम कहीं और से शेयर कर रहे हैं, कहीं और पहुंचा रहे हैं, मेरी दो पंक्तियां हैं कि बड़ी मुश्किल में हूँ कैसे इजहार करूँ, बड़ी मुश्किल में हूँ कैसे इजहार करूँ, तू तो खुशबू है कैसे गिरफ्तार करूँ। तो इस खुशबू को महसूस करने के लिए सिर्फ एहसास की ज़रूरत है। हमारा जज्बा और एंथुजियाज्म और जो हमारी वार्मथ है वो आप तक पहुंच रही है। फूल तोड़ने की ज़रूरत नहीं है। फूल तोड़कर हम सस्टेनेबिलिटी को कंप्रोमाइज नहीं करेंगे। हम फूल की खुशबू का एहसास करके इस चेंज के पार्ट बनेंगे। थैंक यू सो मच।
Thank you, sir. Dear participants, Mr. Sauradipta Chaudhary, sir, is an alumnus of NIT Jalandhar. He has over 2 decades of extensive experience in the IT industry, having previously worked with Cognizant. Currently serving as principal engineer at Nagaro, he is a global leader in digital engineering and has a proven track record of designing and implementing cutting edge cloud native solutions for diverse clients across the globe. Sauradipta is a passionate about delivering end-to-end solutions from conceptual design to seamless implementation and thrives on addressing complex challenges with innovative and effective approaches. Thank you for being part of the session today. I now hand over the session to you, sir, and request you to kindly enlighten the house. Over to you, sir.
Thank you very much. Thanks a lot. Let me share my screen first.
Yes, sir.
I hope it's visible.
Yes, sir.
Well, first of all, thanks a lot for inviting me to share my knowledge with such an esteemed group of participants here. It's always an honor, and I kind of look forward to such an invitation from your group that helps me learn new topics myself before I come here and share it along with all of you. It really gives me a pleasure. Thank you for introducing the topic already. With that, I would quickly get on to the agenda. So I have structured these talks primarily in three categories. First, we will try and understand the impact that IT is bringing on the environment. So all of us are kind of aware of it theoretically, but then I would like to place some numbers in front of us so that we can quantify the problem that we have in our hand. Then we would obviously get into the section wherein we will see how the various leaders in the industry are trying to solve this challenge, what they have been doing, what we as IT engineers are doing and are trying to do. And in the end, we will see how the end users of the IT solutions should do, how should they be using these applications so that the entire ecosystem of sustainability is maintained. Then we'll have some clear call to action and we will see what is the way forward from there. So when we talk about the impact of IT on environment, first let me bring up this term called hyper object, which was introduced by the author Timothy Morton. So according to him, hyper object is a phenomena which kind of spreads beyond the complexity of time and space, right? And it becomes difficult to comprehend for an individual in a very consolidated, one single consolidated view, what that phenomena is all about. And according to the author, climate change is one such phenomena. if you have to define climate change in one consolidated view or in one single definition, probably it would be difficult. It is so big in nature in itself. And when we talk about IT, the impact of IT on climate change or global warming, that's just a very minuscule part of it. But we will restrict our focus of this particular session onto the impact of IT on environment. Having said that, in order to understand that, first let's understand the ecosystem of IT. So when we talk about IT, right, so what we have a set of hardware components, we have devices, we have servers, switches, everything. So there are hardwares which are being running somewhere, in which we are running some of the software solutions like the apps, the websites, the data pipelines, all the documents and the social media content that we are seeing, that are the software part of it, that are running on the hardware components. Now, these hardware as well as the software, they have to be built by a set of people who are the IT engineers, right? Or there are various roles in the IT industry who contribute towards building these hardware as well as the software solutions. There comes the people aspect. So we have architects, we have developers, we have testers, product owners, hardware manufacturers, and in the end, we have the end users who are using those software solutions on the hardware components that we have, right? Now, if you think about it carefully, every aspect of this cycle or every touch point in this cycle would need power to run. The hardware machines that we are talking about, or eventually they will have to run on power. The software solutions, the building of the software solution, that will also have to be done on some sort of a laptop or some sort of a desktop, which eventually would need power. The people using the devices obviously would need some sort of power to make those devices run. So if you think of it carefully, every touch point in this particular IT ecosystem would need power. If you switch off power at any of those touch points, the entire cycle stops. This is what the entire IT ecosystem is all about, and this is where the power plays an important role. I mean, in all of these aspects of it. Now, having understood it theoretically, like I said, I will in the subsequent slides, I will try and put in some numbers in front of you so that we can quantify the magnitude of the problem that we have. I mean, we will see what is the impact in a quantitative way that IT is bringing on the environment, right? So talking about the hardware that we talked about, right? So it needs steel, aluminum, plastic, silicon, rare earth metals, gold, and copper. These are very, very rare metals, and the amount of raw resources that we have to mine in order to get some meaningful material to build these things is immense. Like if you see, only less than 1% of copper and rare earth materials are extracted from the raw ore. The ore extraction process in itself needs massive water usage, right? And the metal extraction and purification process in itself is a very demanding in terms of energy requirements from the fossil fuels. And most of the energy that we use for these processes, they come from the non-renewable fossil fuels. I asked Chat GPT to kind of give me an image of e-waste, right? So why e-waste is important? Because in the end of the day, all these hardware devices, they would have a shelf life. They would expire after a definite period of time. And at that point in time, we will have to dispose them off. And that's the second aspect of the problem here, the e-waste. If you look at this image that Chat GPT has given me, you would see the impression or the perception that's available all over the internet about how big this e-waste problem is. Because at the end of the day, all these LLMs, they are kind of getting trained on the data that is available in the internet, and this is the perception of the overall population with regard to e-waste. And this is the image that ChatGPT has given me, this one here. And you could very well see that the magnitude is immense. There are 62 million metric tons of e-waste generated globally in 2022. The reports are till 2022. And only 22% of this e-waste is formally recycled. The rest of it, they end up as landfills here. So the e-waste problem, after the shelf life of the hardware is reached, we dispose it, and then they end up in e-waste, and we all of us are aware of what the problem of e-waste is. Speaking of the software, there are millions of apps and websites that are running on multiple servers. All these apps, these websites, they are being built by millions of IT professionals that work across the globe. And all of this hardware, they need semiconductors that I was talking about. In this entire process, eventually, like the kind of carbon dioxide emissions that they record, they are very much comparable to what the airline industry does. So airline industry is one of the leading CO2 emission industries that we have. And if you think about it, like I said, if you put in the numbers of the environmental impact of IT on environment, you would see the IT industry is right there, very much competing with the airline industry there in terms of the CO2 emissions. To add to this problem, we have cloud, right? And behind cloud, we have these huge hyperscale data centers. Each data center for AWS, for Microsoft, or Google, they have around 5,000 servers in each one of them. And there are around 7,500 data centers globally, right? This is a small representation of how a data center usually looks like. And you would see there are thousands and thousands of server racked in closed spaces. You need cooling solutions, you need air conditioning, you need network operation centers, etc. In every unit there is the necessity of power, and like I said, the heat exchangers, the cooling rooms, all of them, they need to use water and electricity to kind of dissipate the heat that is being generated in these server rooms. And if you look at the graph at the rate at which these data centers are growing, there would be around 600 to 700 data centers probably by the end of this year, and the rise is very, very, very steep. Now, having talked about these problems, right? So obviously these are challenges. Yes, we know that IT has been contributing negatively to the environment, but then do we stop growing, right? So the question is, should we reduce the rate at which we are innovating, right? Now, if you think about it, I think no, because technology, it's kind of contributing negatively towards the environment. But then if you harness this technology in the right way, this same technology would also give you ways of how to tackle the problem. Having talked about it, if we talk about AWS, Google, Microsoft, the leaders, let's say in the leaders of the hyperscale data centers today, so they have taken a pledge to build a sustainable cloud, right? So like all of us are now aware that yes, climate change is a big problem in hand, and we need to do something about it, and we need to do it almost immediately. And they, being the leaders in the IT space, they have come forward, they have taken the initiative, and following the principles of green IT, so they are they have a roadmap of building a sustainable cloud. Now, what is green IT? Green IT is nothing but it is the way in which the concepts of uh, reuse, and recycle are being applied in the IT's ecosystem as well. And sustainable cloud is just a part of green IT. So like Google and Microsoft, they have been pursuing net zero emissions by the end of 2030 across their entire value chain. Now, the goal is to operate their data centers, their offices on 24/7 carbon-free energy, extracting energy from renewable sources like solar and wind. In this small picture here, you would see in places like Denmark, Google has been setting up a data center which is being run through solar energy. So it's an image of the extensive network of solar panels that they have been laying out. Here is a small video that I would like all of you to watch in the next 3 minutes. So it says how the concepts of reuse, like I was saying, the concepts of reuse, reduce, and recycle have been applied in the AWS data centers, which they call as the circular model, in order to optimally use the power resources. Just have a look. Let me know if the volume is not audible.
AWS is building a more sustainable business. That is what our customers want. And one of the ways we are driving sustainability at our data centers is by expanding our circular economy efforts. I'm Manju Murugesan, and I work on the sustainability team here at AWS. Our strategy for accelerating our transition towards circularity is based on 3 pillars: design better, operate longer, and recover more. By designing better, we unlock more potential than at any other stage of circularity. We design to avoid waste by eliminating excess materials, enabling more reuse and recycling, and using materials that are safer for people and the environment. Next, we plan to operate longer through robust maintenance of data center hardware to avoid early retirement. At AWS, we consolidate individual functional hard drives from multiple aging racks into fewer, fully functional racks, extending the lifespan of S3 hard drives by up to 2 years. By sending only broken drives for recycling and avoiding the early retirement of healthy working drives on the same rack, we increase water and energy efficiency. Finally, we aim to recover more. Through repair and reuse of used equipment, we avoid the carbon and costs associated with the purchase and manufacture of new components and materials. AWS sends securely decommissioned equipment to our regional reverse logistics hubs to assess, repair, and recirculate functional equipment back into inventory or to be sold for reuse by third parties. By designing better, operating longer, and recovering more, we will continue to expand on our circular economy efforts. Our acceleration towards circularity means we use today's equipment to build tomorrow's, charting a path for AWS, our customers, and the global supply chain to reach new levels of resource efficiency and to build a more resilient future for the planet.
So the simple concepts of reuse, reduce, and recycle, when you apply them at scale, you kind of get benefits at a very significant levels. Sure, why it's not moving to the next slide. Yeah, great. So not this one, sorry. So in the Azure data centers, which are run by Microsoft, so they are there's another technique that they're using, which is called as the liquid immersion cooling, right? So like I was showing you, so there are thousands and thousands of servers which are operating inside one data center in one closed space, which means a lot of heat is being generated, right? So, and that heats need to be dissipated in some way. The traditional ways of doing it was by using liters and liters of water to absorb that heat. Obviously, that was not sustainable, and this is a very modern approach that they have brought in. So they are using a dielectric fluid instead of water, and what they're able to do with this is they are recapturing the heat that is being generated from the server operations. That liquid kind of traps that heat, and then in a way that heat can be used in order to heat up other servers for other requirements within the data center, right? So this way they have been reducing energy consumption by 15%. They have been able to drop the consumption, as well as the overall water usage in the data centers have also dropped significantly. There's another video here that's an interesting one. This is an initiative by Google wherein they wanted to give back to the society, and in trying to do so, they also were able to tackle the problem of heat dissipation in a very innovative way. I just want you to have a look at it.
At Egami, we have done what we can to minimize our carbon footprint. We have installed solar panels and reduced our energy consumption. Heating, however, is still a burning question for us.
When we started back in 2011, the challenge was to cool down the servers. But then we found a creative solution: seawater. Just pump it in from the bay. And then we have our heat recovery initiative. Data center creates a significant amount of heat as a byproduct. At Hamina, we have been recovering it for almost a decade now. But then we want to do more.
We have long wanted to channel our recovered heat off-site and to be used by the local communities. After years of extensive work, we are finally able to put our dream into reality right here in Hamina. Finding the right off-taker is crucial. That's why we're delighted to partner with Hamina Energia to share our recovered heat to the local heating network.
Back in 2006, Hamina Energy made the first investment for the wind power production. In 2018, we developed further when we invested for this particular district heating factory. We were able to cut down the emissions, and then also we were able to cut down some pricing for our customers as well. This new cooperation with Google would ensure even more affordable and sustainable heat for the customers in Hamina Energy district heating network.
For Regami, education and sustainability go hand in hand. They help future generations thrive. Google's bold work in Hamina doesn't just warm our bodies, but our hearts as well.
Hamina is only the start. Heat recovery is a major opportunity for energy conservation and transition, and Google is working to make it a reality in our data centers worldwide.
Quite interesting, isn't it? Well, now that we have looked into what the innovations are that were being done in the data center operation side of things, let's quickly move on to the next slide, wherein we will see what the software development, sustainability principles in software development would look like, right? So there is one website called as the greensoftware.org, wherein you will see certain principles, guiding principles for how to design a software solution so that eventually they end up being sustainable. So there are 3 P's of sustainable design: practices, patterns, and principles. So so this website says that there are practices which should follow. The practices should lay down certain patterns. The patterns should then again lead to certain principles. So there are certain design principles which in the past there were design principles around performance, there were design principles around security. So right now we have design principles around sustainable architectures as far as software solutions are concerned. Now, to summarize, what are these design and coding principles that we have? So what it says is we should adopt shared resource models. Like, let's say if there is one server wherein you are running one website, and if that server is not being fully utilized, let's say the amount of compute requirement for that one website is lesser than what that server can provide, then obviously there is a room for optimization, and you should be deploying multiple websites onto that server instead of spawning up a new server for each of these websites. And how does it help us? Obviously, all of us can understand, if we have to run one server compared to multiple, that means we would be saving a lot of electricity if we switch off the other servers. Then they also talk about breaking down a large monolith application into microservices and dedicating or allocating resources, compute resources, only to those components in the software that actually need them. So if there is a certain component which is being used heavily, allocate just in time more resource to that particular component. And if there is a component which is not being used or is being used rarely, do not waste any resource by permanently allocating it to that particular component. Obviously, there are just-in-time computing principles, event-driven approaches, wherein do not run empty processing cycles. Only run your code when there is some data to process. If you do not have any data, do not run that cycle, thereby save the running costs. Reuse pre-computed data, caching. Obviously, if there is a computation which kind of generates the same data again and again on a fixed set of data, do not do the recomputations again and again. Pre-compute them, keep them saved, and deliver it as and when required. Large static data close to the end user to reduce network hops. So let's say you are sitting in India, you're watching Netflix. Obviously, it does not make sense to stream your video all the way from Europe. Instead, there should be a server in India which contains the Netflix videos, and they would stream it from India. The amount of network hops or the amount of network switches that that data will have to cross would be quite lesser, and that is where you would also save energy, not just performance, energy. So if you look at all of these principles to my left, the architectural principles, and if you think about it, these are not new principles, right? So even in the past few years or in the past decade, when we wanted to optimize the performance for an application, the latency of a website, the availability of a solution, these are the same principles that we were kind of using. It's just that we did not realize that the same principles, if applied, would also help us in being able to develop sustainable solutions. And this is where, we the architects, or we the enterprise solution architects, or the product owners of an IT industry should play a role. In my opinion, whenever, let's say, we are building a solution for the customer, we might be talking about performance, we might be talking about availability, but then sustainability should also have its dedicated share of time in our discussions, right? So we should constantly keep on bringing up this topic in all our solution designs that we present, that yes, this is highly performing, this will have no zero or low latency, high available, but yes, this will also be a sustainable solution, because at the end of the day, if the enterprises, the business houses, if they do not adopt sustainability, we won't be able to deliver sustainable solutions. Coming to the coding principles, like when we write our code, or the kind of UI applications we build, so we should focus on designing UI which is eco-friendly, like low resolution. If you do not need a very high resolution for a certain, let's say for an educational website, you do not need any fancy graphics or anything, so do not make it unnecessarily fancy, right? So if the requirement, or if the use case does not demand high resolution, do not go for a high resolution solution, go for a low resolution solution, low resolution images. Build your websites on darker themes, at least give them an option to switch to darker and light themes, because darker themes would emit less warm energy, right? Then we should always choose algorithms when we are given a problem to solve through a piece of code. We should always think about the logic which will which will complete in less amount of time, which is less complex, reduces the number of iterations or operations, or the third party calls. Because if we keep it simple, if we keep our algorithms complexity simple, eventually the processing time would reduce. And like we already understand now, if we reduce the processing time, that means a certain component in some server will run for a lesser amount of time, thereby needing less amount of electricity and generating less amount of heat. Efficient data structures, trees, hash tables. So we should take a very conscious decision on how we design our code, what kind of tables we are using, how is the table relationship, etc. And then obviously go on using linear OS images through the principles of containerization, which eventually leads to microservices. So again, I would like to stress on the fact that if we think deeply, these are nothing new. We will not need to learn anything new in order to build a sustainable code. It's just that we need to wear a hat of a sustainable engineer, and also think from that perspective, right? And when we pitch our solutions, when we pitch our solution designs, we should talk about sustainability, how sustainable our designs are. Once we have built softwares, we should also track, we should have an option of tracking our carbon emissions, right? So let's say at the end of the day, when we have built a software, we would eventually deploy it in some sort of a cloud environment, be it Microsoft, Google, or AWS, or anything else. Almost everyone has a sustainability reporting tool available to them. So they report the amount of emissions that your solutions are contributing, and you can have a close monitoring of those emission levels and accordingly tweak your solutions or policies based on that so that you remain within your sustainability standards. Europe, for example, has a very strong has very strong norms around reporting their ESG data. Almost every organization has a mandate of sharing their emission reports to some regulatory body, without and not doing so can incur penalties. In India as well, SEBI kind of guides that. So the top 1,000 companies by market cap registered on the stock exchange are required to are required to publish their ESG reports. However, as far as the mandates or penalties are concerned, they are not as stringent as Europe. But yes, there is a norm, and these norms need to be enforced more regularly and with more emphasis in order to eventually come up build sustainable ecosystems. So last but not the least here, so we have talked about how the leaders, the IT leaders are, playing their part, how the developers, the architects are playing their part. In the end of the day, it comes down to the end users of the application. The number of end users that we have today for digital applications is immense. And we kind of have the concept of digital consumers here, right? So we need to use our devices responsibly. And if let's say some of the guiding principles are like, before we purchase an electronic equipment, we should check its ratings, right? So we should not buy a low rating equipment which kind of is not energy efficient. Obviously, we should switch to low resolution content unless we are watching a sci-fi movie or something. We don't need some resolution, so why not switch to low resolution and save the planet? Shut down when not in use. Again, very, very basic principles which have been taught to us since ages, but now it plays an even more important role. Switch to Wi-Fi instead of mobile data. Obviously, Wi-Fi, the energy consumptions of a Wi-Fi is kind of less compared to a mobile data. So if you are in your house or in your office and you have an option to connect to a safe Wi-Fi, mind it, safe is a very important one. Don't just connect to any Wi-Fi. If you have an option to connect to a safe Wi-Fi, please switch to Wi-Fi. Buy refurbished products if possible, instead of buying a brand new product every time. If you buy refurbished products, somewhere you are contributing to reducing the e-waste in the planet. Just don't store photos or videos just because you can buy cheap data storage, right? So if there is some video or some photo which you do not need, take some time out, clear your hard disks or your cloud storages, because the amount of data you store eventually eats up some hard drive in some data center, which is made up of semiconductors. And again, like semiconductors are rare earth metals, and a lot of energy is consumed in manufacturing those metals. Use zip formats to archive files. If you have files which you don't need regularly, you can zip them. Zipping them reduces their size and thereby needs lesser amount of storage. Just adopt eco-friendly digital habits. Reduce the social media scrolling just for the sake of it. You want to watch something, directly go to the video and watch it. Yes, it would, obviously it would improve your sleep and everything. Like there are other guidances around why you should not be scrolling your social media, but it would also help the planet. So think it from that aspect as well. Save bookmarks instead of searching the page every time. So if there is a website you visit regularly, just don't type the website and fetch it, or don't search it from Google every time and then hit on the link, bookmark it so that you can save that search cycle in Google. Again, reduces the processing time somewhere. I would like to stress upon this point again. Talk about sustainability continuously to raise awareness. So unless all of us are at the same page, or unless all of us are equally aware of the problem in hand, this will not go away. And even like thinking that yes, whatever damage had was supposed to happen has happened, what can be done, right? So that's also not the right way of thinking it. A good act is also, I mean, if you do something to reduce the bad impact, that itself counts as a good work towards sustainable approaches. So talk about it continuously in any forum that you are a part of, with your colleagues, with your friends. Keep talking about it so that the awareness is high. Well, some clear call to actions. This is a report from NASSCOM. Now, like what we see here is, yes, the awareness has crept in at the enterprise level. The government also, like I said, across the globe, different governmental organizations are bringing in mandates in some way or the other for the organizations to be more and more sustainable. And building sustainable approaches, building sustainable products, or adopting sustainable ways of working is one of the top priorities in almost every organization across the globe now, right? So which means there will be more and more projects which will demand sustainable solutions, because at the end of the day, like I said, in Europe, if every organization has to report their ESG numbers, they would also want to have sustainable solutions, sustainable products, sustainable IT products running in their running in their ecosystem, because everything adds to their emission levels. AI, the big thing now, it has its own challenges when it comes to sustainability. They need power hungry processors. They need the long training periods that are required to train an LLM. Needs a lot more power than we can even imagine. Google has said that AI is one of the reasons for falling short of their company climate goals. Like I said, there was a pledge that they would be net zero emissions by the end of 2030, but because of the boom in AI, they are struggling to kind of meet that standard. I mean, AI can generate overconsumption as well, right? So just because you have a chat GPT at your disposal, you would have the inclination of doing anything and everything on chat GPT in the coming days. And that means even if you do not need something, you would just, for the sake of it, type it in a chat GPT and see how it responds. And then again, everything leads to that processing cycle somewhere on the earth, across the globe. If the moment you do an operation on your laptop, some process kicks off somewhere, energy consumption is written, all the footprints, you see it everywhere. Now, AI is not all bad, right? Obviously, we know. Like I said, if technology has caused the problem, then technology, if harnessed in the right way, can also help you in coming up with solutions to that problem. So the AI models can help data centers, come up with the best models for cooling distribution, the heat dissipation, etc. So if you use AI to think around solutions of how to reduce the heat generation and how to reduce the consumption of electricity, you might even come up with solutions quicker than you otherwise would have. Sustainable AI is a concept these days. So use existing models. If you have a model trained which can solve your use case, use that model instead of going ahead and training a new model, because training a new model means a lot of power consumption all throughout. Use a specialized model, use a small model if you have a very special task. Don't just go ahead and use a large model which needs to do a lot of computation in order to respond to you. If you have a very specific need, if there's a specific model available, select that. So do your due diligence in terms of which model to use for what kind of an activity. Quantum computing, although not as popular as AI currently, but it probably will be at some point in time. It also has its own climatic challenges, because quantum computers, they they need to be operated at temperatures very close to zero. And in order to maintain these kind of temperatures, you need a lot of intensive dilution refrigerators, which are again very power hungry. Now, fabrication of quantum specific chips and superconducting materials is again resource intensive, and obviously mining those resources from renewable sources of energy, from non-renewable sources of energy, it adds to the overall problem big time. But again, quantum computing also can help us in solving the problem. How? Because they would be capable of running very complex algorithms in very short period of time, which otherwise would not have been possible with the traditional computers that we have. And if we are able to simulate very complex problems, then we would end up discovering better battery materials, even more optimized grid planning, logistic routing, simulating the molecular interactions. So in a nutshell, this could accelerate the environmental breakthroughs, which otherwise probably would not have been possible with the traditional generation of computers. So that's a positive side that we can look forward to in future. Sorry, it's stuck, I think. Am I audible or am I hung?
Sir, you are audible. Only the slides have, I think.
Okay. Yeah.
Yes,
I
they
think.
have moved.
Yeah. So how can the academic brain power help us, right? So if we look what we have on the screen, the UN has come up with the 17 SDG goals. They call it the best plan for the world, and maybe the research around each one of these components can help us. So there's a small video around it with which I would like to end. So these are the 17 sustainable development goals which have been identified by the UN, and the academic brain power, I believe, are focusing a lot of research work around each of those aspects, and eventually we would see a lot of good work, a lot of improvements in every quarter, and hopefully we would see a more sustainable planet in the coming years. With this, I would end my session here. I hope I was able to impart some knowledge, and
Thank
I
you,
would
sir.
stop sharing my screen as well.
Thank you, sir. Thank you for the insightful session. It has been really insightful. Especially, I would say, I hope this session has helped woken us up, all up, that even we can contribute towards making this planet and converting IT operations into a more sustainable operations. Yes, there are a few questions, sir, which I would now like to take up with your permission.
Absolutely.
So one main question that I see, which is very interesting, the initial expense of implementing energy efficient, sustainable infrastructure can be very high for a medium scale or a small scale enterprise, especially in a country like India. So, will this not create a green divide where only privileged companies can actually go towards accessing green solutions?
No, so it's not that the green solutions would be expensive to build, right? So like I showed the principles. Let's start from bottoms up, right? So let's say I'm developing a code which I want to run somewhere, right? The principles of sustainable coding are not new and expensive. Like I said, the architectural design principles that would help us in achieving sustainability, these are the principles which we anyways have been doing to optimize the performance also. It's just that we need to be aware that even if we do not need an optimization, just because we need a sustainability, we still have to bring in those principles, right? So they are not expensive. And secondly, almost everybody would run their workloads on cloud these days, right? So in some sort of a public cloud or a private cloud, right? So the expense of the innovation is being borne by those leaders there, right? So if you host something on AWS, they are doing their bit to make their data centers energy efficient. So the expenditure is there, right? So eventually building a software these days is not that expensive using the sustainability principles, right? It's more about deciding, like I said, if you like understand your use cases well, right? Just because you want some technology in your kitty, don't use it. If there is a use case, like I said, if you're an educational institution, you don't need a fancy UI solution or anything, right? So be conscious there. So that is where it will ultimately come in.
Absolutely, sir. Very rightly said. Another interesting question, sir, I can see. Would it be possible to combine all the 17 sustainable development goals into one particular ecosystem?
Uh, Probably that's a UN question, but then since they have come up with 17, goals, obviously, if you ask me, I'm from a layman's perspective, if you want to solve a very big problem and in one shot, it might seem undoable kind of an activity. But if you break it into atomic levels and try targeting one at a time, or at least you know allocate multiple teams, one to each, eventually the collective effort you will be there. But if you take it as one big monolith and try to solve it, maybe that might seem unimaginable kind of a job. Maybe that is why they have broken it into 17 goals. Yeah.
Absolutely, sir. So one last question that many of the participants would like to know. As respect to India, are there any government regulations that make green coding and sustainable practices a compulsion for everyone?
So like I said, right, so in India there is a body SEBI, right? So which kind of I won't say it's a strong mandate, but then it kind of enforces the first 1,000 companies registered listed in the stock exchange by market capitalization, by the size of their market cap, and they are kind of mandated to share an annual ESG report with SEBI. Right now, if they do not share that, I don't think there are any penalties associated with it right now. But then yes, so there is an initiative which kind of requires them to share it annually, but in India, and I think if Europe is the, I think, most advanced in this case, wherein the European Union, it kind of enforces all its member states to incorporate ESG into their national law, and kind of have some penalties associated with it if you do not publish your ESG reports. So that is why I was saying, across the globe, in most of the European countries, the IT projects that we see, there is a separate division which kind of deals with ESG reporting for that organization. And for every project, they kind of need the data, how sustainable that project is going to be. So the norms are stronger in Europe, but in India there is a norm, but it's not that strongly mandated. But yes, again, I mean, unless and until you kind of bring in strong mandates, you won't see a change. and that is the need of the hour.
Absolutely. That's very right, sir. And I would say it is more what we get to learn, that it is a collaborative responsibility. Each one of us will have to contribute our part if we want to actually ensure a sustainable future for us as well as our upcoming generations.
Absolutely. Keep talking about it. Like I said, you have to, keep talking about it everywhere with everyone so that the awareness is there. And eventually, maybe we'll see the light at the end of the tunnel, as they say.
Absolutely. Very rightly said, sir. So, on that positive note, I think we will come to an end to this beautiful and wonderful session today, but not before we thank sir. So, I would now request Professor Emin Huda, sir, to kindly thank Sauradipta, sir, for this wonderful session with e-memento and certificate. Sir.
So thank you so much. It has been a superb session wherein we have been talking about sustainable IT in terms of using responsible technologies. The people in due course of time when will be realizing that using responsible technology is also a very, very important factor, particularly in digital age, when everything is running behind the technology. So thank you so much. This certificate is not for the purpose of certification, rather for the purpose of remembrance. And memento also, please.
Yes, sir.
And we are using technology in a responsible manner. So not
Absolutely.
printing even certificate, not printing even memento, not wasting anything, and contributing to sustainability. Thank you so much, Mr. Solve.
Thank you very much.
We'll meet
Thanks a lot.
again on this platform. And thank you so much to all my friends. This meeting room is converted into a facilitation center to resolve your queries related to certificates. Over to you, Dr. Ritika.
Thank you, sir. And thank you so much, Sauradipta, sir, once again
Thank
for
you,
this
Ajay ji.
wonderful session.
Thank you, Jay. Bye. Thank you, Sauradipta. Yeah.
Thank you. So I'll drop off then. Thank you.
Yeah.
Thank you, sir. Dear participants,